Hello and welcome to this week's videos on our course Competition Policy and Strategy. This week we are going to talk about the solutions to assignment number 10 on horizontal as well as vertical cooperations. In the first exercise 10.1, we are going to talk about the topic of information exchange. And we are going to do so in the following model. We are going to assume a situation of a market with differentiated goods. There's two firms competing in a Bertrand competition. Both duopolists know the market demand, which reads Qi, so the demanded quantity for good I, as a function of the price of good I as well as the good J, Pi and Pj, equals 110 minus Pi. 110 minus Pi plus 0.5 Pj. The marginal costs of the firm 2 are common knowledge. That means everybody, that includes both of the firms and us, knows the costs of firm 2. Marginal costs of firm 1, however, are private information to firm 1. That means only firm 1 knows the marginal costs of firm 1. Alright, now as a starting point, we are going to calculate the market equilibria for low costs of 10 and high marginal costs of 40 when both Bertrand duopolists have perfect information regarding the realization of costs. So we are basically simplifying the model in order to create a benchmark situation once again, so we can use this as a reference point for future results. Alright, so for a second we are now drop the assumption or this model property of uncertainty and instead consider a benchmark situation where both firms actually have perfect information regarding the realization of costs. Still, we are going to consider two versions, two worlds of this model. In one version, firms have low marginal costs, and in the other, firms have high marginal costs. So, the profit function of the duopolists in general read the profit pi I for firm I equals the margin, the profit margin of firm I, so Pi minus C, the marginal costs of the respective firm, times the quantity demanded, which is of course the demand function we were discussing or introducing earlier. So in general, for any C, regardless of it being CL or CH, the reaction functions of both firms, both of these symmetric firms in this version, read Pi equal 110 plus marginal cost C plus 0.5 Pj, all divided by 2. So from this we can now use these reaction functions to analyze both of these given situations. One situation where both firms have low marginal costs of 10 and one situation where both firms have high marginal costs of 40. Situation 1, low marginal costs, we simply plug in the low marginal costs into the reaction function that we derived earlier. And if we do so, well, we then have two symmetric reaction functions. We can solve this to find the market equilibrium simply by plugging in Pi as a function of Pj into Pj as a function of Pi, the usual way that we solve a model given two reaction functions of one for each firm. Now, if we do so in the situation where we have low marginal costs for both firms, we see this market equilibrium where the price is 80, quantity is 70, and profits are 4,900. At the same time, if we consider situation 2, where both firms have high constant marginal costs of 40, we again plug in CH into the reaction function we have defined or found earlier on the previous slide, and using this we can then calculate profit, quantity, prices in market equilibrium for these two symmetric firms. In this case we have an equilibrium price of 100, a quantity of 60, and profits of 3,600. All right, now let's go back to the world where we actually have uncertainty with regards to marginal costs of the firms. In task B, we are now asked to calculate the reaction functions of firm 1 and 2 in general. If the costs of firm 1 from the point of view of firm 2 are uncertain in the sense that they realize with a probability of 50%. All right, so we are now back to the model we described in the very beginning, where the actual costs of firm 1 are private information of firm 1, and firm 2 has to build or has to form expectations regarding the actual costs of firm 1. And we are going to assume that both of these states are of equal probability, so that high costs as well as low costs are both realizing with a probability of 50%. Costs of firm 2, again, costs of firm 2 are non-private information, they are public information, all firms know this, are going to be labeled C2. So for now we are not going to make any assumptions on whether or not firm 2 is going to have high or low costs, but we know that there is no probability behind this, but instead it is deterministic, unlike the cost of firm 1. All right, let's do this. The price, first the price and cost set by company 1 or firm 1 from the point of view of firm 2 are in the mean as it is written down here. All right, so the marginal costs of firm 1 again are private information to firm 1. So from the point of view of firm 2, costs of firm 1 are with equal probability large or high. So we have this weighted marginal costs, 0.5 times CL plus 0.5 times CH, which in this case of course equals 25. This is nothing else but the expected value of the marginal costs of firm 1 for a situation where each possible state is equally likely. Same is true for the price that firm 1 will set. So from the point of view of firm 2, the pricing strategy of firm 1 is equally likely for low costs and high costs. So if firm 1 has low costs, they will set a price according to their low marginal costs. And if firm 1, on the other hand, has large marginal costs or high marginal costs, it will set a price according to their high marginal costs. Now, both of these worlds are, from the viewpoint of firm 2, equally likely, which implies that the expected price of firm 1, P1, with a superscript E for expectation, is again the weighted sum or the expected value of both of these prices. Now these prices follow the reaction functions which we previously described. So P1 is a function of P2, a reaction function of P2. So by plugging in these reaction functions, we can then calculate an expected reaction function for firm 1 from the point of view of firm 2. Again, just to reiterate, of course firm 1 knows its actual reaction function and will behave according to its actual realized reaction function. This, however, P1 with the superscript E denotes the expected reaction function expected by firm 2, the expected reaction function of firm 1 as expected from firm 2. Alright? So firm 2 is building an expectation with regard to the best response of firm 1. Alright. Now if you want to find the equilibrium of this market, we again have to or in the usual way, we have to find the intersection of, graphically speaking, the intersection of these reaction functions. Or mathematically speaking, we have to solve by substitution, for example. We know the expected best response for firm 1 from the point of view of firm 2, and we know the deterministic best response of firm 2. So in order to find the market equilibrium, we have to find firm 2's best response to the expected reaction of firm 1, right? So we are now looking for the intersection of the deterministic reaction function of firm 2 and the non-deterministic, this uncertainty incorporating reaction function of firm 1. All right. So we can basically substitute these reaction functions into one another to find the equilibrium. What is happening here is that firm 2 is maximizing their profits in the usual way a function of the prices of firm 1 and firm 2. They are maximizing their profits by choosing their strategic parameter P2. However, what is their profit function? Their profit function depends on the price of firm 1. From 1's price, however, as we have established, can take two separate values with equal probability, right? So one way to formulate this is these first two lines, where we have with probability 0.5 a profit function for firm 2 that incorporates a low price of firm 1, and with the same probability of 0.5 a profit function of firm 2 that incorporates a high price of firm 1, right? Equal probability once again. This, of course, is the same as what's written in the next line, where we already combined these two probabilities. You will realize that all of the other terms are non-deterministic, which implies that we can simply plug in the expected price of firm 1 from the point of view of firm 2 right here, right? Okay, now given this expected price setting behavior from firm 1, firm 2 will now maximize their profits by, as in the usual way, maximizing over the choice of price 2, right, of their own strategic parameter, which then, if we follow along, so we calculate, in order to find this profit maximum, and we state the first order conditions of this maximum, which implies calculating this partial derivative of profit function of firm 2 with respect of price of firm 2. If we do so, we arrive at this reaction function down here, which looks exactly like we usually expect reaction function in this differentiated Bertrand world to look like. Only difference being this price of firm 1, which of course is not simply a deterministic price, but rather is the expected price, the expected price which we have stated earlier right here. So now we have a reaction function of firm 1 and a reaction function of firm 2, or an expected reaction function of firm 1, and the deterministic reaction function of firm 2, and based on this we can then calculate market equilibrium. All right. Yeah. Continuing from this, we are now asked to actually calculate the equilibrium prices based on the reaction function we have stated. But if you remember, we have not yet determined whether or not whether firm 2 actually has high or low marginal costs. We simply treated it as a parameter and said, well, it is deterministic and it takes value C2, right? So we now have two options, and that is, first, C2 might take a value of CL, so the low marginal costs, or alternatively, it takes a value of CH, the high marginal costs. Of course, this is not a matter of probabilities. We don't need to form expectations at this point, but rather, right, because costs of firm 2 are unknown. So we are now simply analyzing two different versions of this model. One where the costs of firm 2 are low, and this is common knowledge that firm 2's costs are low. And then second, that firm 2's costs are high. And again, this is common knowledge as well. Okay? So let's just compare these two versions of the model. The first version, let's consider that firm 2 actually has low marginal costs. Right. For this situation, we know, for this situation, we now plug in the low marginal costs of 10 for C2, the parameter which we left as a parameter previously down here, and can then solve for the actual equilibrium prices of both firms. Just remember, we have found the best response functions earlier. We can then substitute the best response of one firm into the best response function of the other firm, and then result with a function that only depends on the firm's own price. If we do so and then consider the deterministically defined marginal cost of firm 2 as well, we then find out that firm 2 will set a price of 82. This price of firm 2 comes with an expected price for firm 1 of 88. Expected in the sense that the actual price still depends on the realization of the marginal costs of firm 1, which we don't know yet. So we have to form an expectation in the same way or in the exact way we discussed in the previous slides. But the expected for the expected marginal costs, which are with 50% CL, with 50% CH, so 25, for this expected marginal costs, we would see this expected price, which takes a value of 88. Now towards the second version of this world, where firm 2's marginal costs take a value of CH, so 40. We do the exact same thing, of course. We simply plug into our equilibrium results from the previous slides. We now plug in C2 equals 40, and then we know that the equilibrium price of firm 2 equals 98. And for this equilibrium price of 98 for firm 2, the again expected equilibrium price of firm 1 would be 92. Of course, exactly like on the previous slide in the alternative version of this world, this price of 92 will never realize. It is the expected price. Firm 1's costs will never be equal to the expected costs, right? The expected costs are actually impossible to reach because they will either be low or high, but not in the middle. So this price will also never be observed, but rather it is the expected price for an equally likely world where firm 1 has low marginal costs and a world where firm 1 has high marginal costs. All right, now finally we were asked to plot this response function in a graph. So let's start with this middle blue line up here, R1e. So the reaction function of firm 1, the expected reaction function of firm 1, right? So the reaction function that is expected from the point of view of firm 2. The reaction function up here is the actual reaction function of firm 1 if the realized marginal costs is low. And accordingly, down here we have the actual reaction function of firm 2 if the realized cost of firm 1 is high. Whether or not, or whether we are in this state up here or in this state down here is again private information to firm 1. Only firm 1 knows this. So from the point of view of us and firm 2, we need to consider this middle function, the expected reaction function. Right. Firm 2's reaction function, the blue line that is down here, less steep, R2, of course, is deterministic. Right? There is only one single reaction function because the reaction function is deterministic. There is no probability with regards to the marginal costs of this firm. Right. All right. Now these two horizontal lines in black and in red that we see is the market equilibria in case firm 2 actually had large marginal costs. So the second version of this world which we analyzed previously. And down here in red we have the situation where firm 2's deterministic costs are low. So the first version of this model world that we analyzed previously. And what we realize is that in this intersection, in this part, let's for now just consider this red line. So firm 2 has, by assumption, low costs deterministically. Firm 1 has unknown costs, at least unknown to us, the observer, and firm 2. Then the market equilibrium is in this intersection of the red line and the middle blue line. So the expected reaction function of firm 1 and the reaction function of firm 2, right? Now we have already denoted or marked all the other intersections between reaction functions and the deterministic set price of firm 2, and we will come back to this in a moment when we are comparing different states of this world. Let's just consider 2 points as an example. So we said that in a world where firm 2 has low costs and has to form an expectation regarding firm 1's costs, we are in point C. Point C implies a price from firm 2 that is right here on this axis. This price, this expectation building with regards to the reaction function of firm 1 results in a price for firm 2 having low costs that is in this point right here. Now, firm 1, of course, as we said earlier, will never actually have this middle reaction function, but rather, instead, firm 1 will always either have high costs or low costs. So, from the point of view of firm 1, it will always be the case that either this lower reaction function or this higher reaction function actually holds true. Right. Now when we compare points E and D to one another, what you will realize is point E is in the intersection of the reaction function of firm 2 and this reaction function for high marginal cost of firm 1. So, in a world where there was no private information and both firms knew the reaction function of one another, this point E would be our market equilibrium. However, because there is uncertainty, firm 2 will not actually set a price according to point E, but rather according to point C. Firm 1 at the same time will take this price-setting behavior of firm 2 into consideration. And for this price marked in red, for this pricing from firm 2 that is marked in red, we will find a profit maximizing or a best response price of firm 2 in the intersection of the red line and this reaction function of firm 1, which is point D. And point D comes with a lower price of firm 1 than point E, right? Without going into the details of the direction of this change, what at this point I want to highlight is that this uncertainty with regards of the actual costs of firm 1 results in different equilibria than we would see if there was no private information. A comparison between these different equilibria is exactly what will follow in the subsequent tasks. Alright, so let's continue with these comparisons. First part is we are asked to compare the equilibrium prices and profits of firm A1 and 2 under full information, so under A, with those under uncertainty. Assume that firm 2 has low costs. So, not a coincidence, we are continuing to assume firm 2 has low costs. That means firm 2's pricing behavior will be the red line and this blue reaction function, right? But one thing after another. Compare the first part we were asked to compare were prices and profits under full information, so under A. And we can actually see these prices in this graphic, right? Because as I have alluded to earlier, this is the actual reaction function if firm 1 had low marginal costs. And if both firms knew this, if this wasn't private information, well then the equilibrium price would be in the intersection of this reaction function and firm 2's reaction function, which is this blue line down here. Right, so point A down here. This point A is the market equilibrium, the prices for both firms in a world without any uncertainty. Analogously, if we want to find prices of both firms in a world without any uncertainty, but now firm 1 realizes costs that are of CH, so large costs, we now need to consider this reaction function down here, reaction function of firm 1 for CH. And again, in order to find the equilibrium in the world without any uncertainty, we simply find the intersection of these two reaction functions once again, and then we are at point E, as I have discussed or said earlier. So the results of task A are already in this graphic. So complete information, the Nash equilibria, right, the best responses to the best responses, Nash equilibria, are in point A and point E. Under uncertainty, however, we will see point B or point D. Let's start with these two, point D and point B, where this one down here, this one up here, right? So the best response of firm 1 onto the best response of firm 2, where firm 2 has to form expectations and therefore sets this price under C, right? The intersection between the best response of firm 2 and the expected reaction function of firm A, firm 1. This price, however, this price that firm 2 sets in this point C is then taken into consideration by firm 1 for both states of the world. So if firm 1 actually realizes that it has, or that it has low costs, well, then it will set prices according to point B, where it takes this probabilistic price setting behavior of firm 2 into account and sets a price according to this red line. And the same happens, of course, for a realization of high marginal cost for C1. So on this reaction function, where then in the exact same way, the equilibrium does not lie in the intersection of the reaction functions, but rather in the intersection of this red line. Again, this comes from this price setting behavior from firm 2 not knowing which reaction function is correct, and the intersection of this price setting behavior and the red line and the reaction function under high marginal costs. So in point E over here. Then there is one final equilibrium under uncertainty, which is point C, which we have talked multiple times about by now, which is a Bayesian equilibrium, meaning that this is the equilibrium considering that both states of the world, C1H and C1L, realize with 0.5 probability. So this never actually realizes this equilibrium, this never materializes, but for this given probability, this is the equilibrium based on the expectations of firm 2. All right, now this is prices and profits for all of these equilibriums. How do we calculate them? Well, all of these prices, of course, they were implicitly written in this graphic. How do we calculate them? Well, we calculated equilibrium prices based on the reaction functions we stated right at the beginning of this exercise. And you will find each of these price combination by considering the appropriate reaction functions, either in a deterministic way, which we did under task A, or in this probabilistic way, which we did under task B. Right. So this is just the prices and the profits from these different equilibria. In the next step, we are now talking about interpretations of this. We want to interpret these differences in profits that arise under uncertainty or not uncertainty or certainty. So assume that companies can exchange information with each other before interacting in the market. What incentives arise? Consider the following cases. First, the information is verifiable, and second, this information is not verifiable. All right, so what incentives arise? Let's start with this point. The incentives for information exchange. What we can see is that if firm 1 has low costs and it would the information available, that would result in a loss of profits. So let's compare point C, where there's uncertainty, with point B, where firm 1 actually has low costs, and consider whether or not firm 1 wants to communicate or has an incentive to communicate that its actual costs are low. Let's compare point C with point B. So does firm 1 want to move from a point C to a point B? Let's compare profits of firm 1. See, profits of firm 1 increase, profits for firm 2 actually decrease. So if firm 1 actually has low costs and it would make the information available, this would result in loss of profits. The equilibrium shifts from B to A. So, shifts from B to A. So the profits of firm 1 actually decrease by 70, right? So we are starting, or the starting point would be point C. Let me just mark it on the graphic. Actually, this point where there is uncertainty, and the equilibrium that would result in this situation where firm 2 does not know what the actual costs of firm 1 are, where, as we discussed, the intersection of this red line, the price setting behavior of firm 2, and in this case, the low marginal costs reaction function of firm 1. So in the world with uncertainty, the equilibrium is in point B. If we want to analyze whether or not firm 1 has an incentive to tell the truth regarding their actual realization of their costs, we need to compare this equilibrium under uncertainty to the equilibrium that would arise under certainty, under perfect information, which is, of course, the intersection of both reaction functions, so point A down here, right? So by telling the truth regarding their costs, firm 1 would be able to shift from equilibrium B to equilibrium A. So let's compare equilibrium B to equilibrium A, compare once again profits of firm 1, and we see profits decrease in exactly the order of magnitude that we said earlier. So firm 1 is losing in profits if they chose to tell the truth and tell their costs. Right, so we have no incentive or a negative incentive for firm 1 to tell whether or not for firm 1 to tell its true costs if it has low costs. That's 50% of the story. Let's consider the other 50% of the story. So what are the incentives if firm 1 actually has high costs? And once again, what we are looking at is the pricing behavior of firm 2 under uncertainty, which is again this red line. Under this red line, firm 2, the equilibrium will be this combination in point D, right? So the intersection of reaction function for high marginal costs in this case with the price setting behavior of firm 2 under uncertainty. So we are in point D in the world where there is uncertainty. By removing this uncertainty, we would move to the intersection, or the equilibrium would move to the intersection of these two reaction functions, which, as we have discussed earlier, is point E. So let's consider profits of firm 1 moving from point D to point E. Point D to point E, compare profits of firm 1. What we see is profits increase, okay? So in this setting, if the actual marginal costs of firm 1 are large or high, we see that there is an incentive of firm 1 to tell the truth and reveal their actual costs. That should be written on the slide as well, right? If firm 1 has high costs and it would make the information available, this would result in an increase in profits. The equilibrium shifts from D to E, so we have this increment in profits for firm 1. So clearly firm 1 in this case has an incentive. So kind of contrary results depending on which state of the world we are actually in, right? If firm 1's realization of costs is low, then it does not have an incentive to tell. If its actual costs are high, it does have an incentive to tell. Okay, what does this imply? And in this, consider that information may or may not be verifiable. Starting with, information is verifiable, so firm 2 knows whether or not firm 1 lied. So, due to the given incentives, as we have discussed, firm 1 will only communicate their large costs if their cost is high. Only then they had an incentive to tell and to reveal their costs. However, firm 2 can now, of course, infer the true costs of firm 1. Because, well, if it communicates, it has high costs, and if it does not communicate, it has low costs, right? This is true because firm 1 cannot lie. Information is verifiable. So, from a non-communication of firm 1, firm 2 can infer that it actually has low costs. So, in this case, the equilibrium would be reached in point A, which, there we are, is the situation where there is no uncertainty at all. All right. Second part, information is not verifiable, so firm 2 cannot tell whether or not firm 1 lied. In other words, firm 1 is allowed to lie and to get away with it. In this case, if still the same basic concepts hold true, right? If firm 1 has low costs, pretending to have high costs, would firm 2 to believe this and set a price of P2 equal to 85. However, since firm 1 has in fact low cost, it sets a price of 81. So what firm 1 can do is tell it would have a high would have high marginal costs, which would imply, jumping back to the graphics because I think it's way more intuitive showing on here. So in this world, this is the actual truth. Marginal costs are high. However, firm 1 can lie and tell that their actual costs would be low. In this case, we would see an equilibrium or a price-setting behavior of firm 2 that is this price, and then firm 1 can take this price and the intersection of these reaction functions into consideration for their actual reaction function, which they lied about, the actual reaction function, which is of course for high costs in this world, right? So in this case, we would then again map this this price setting behavior of firm 2 onto the reaction function of firm 1 and thereby get the profit maximizing pricing of firm 1 as well. Okay? And now if we analyze this, what is the actual prices of the firms if they lie? Yeah, this is what we see. So pretending to have a low price is actually worthwhile for firm 1. It is profit increasing. Right. This is one of the two possible scenarios of the world. The second one is if firm 1 has high costs, it would again increase their profits by going from point D to point E. So by leaving the state of uncertainty and revealing their true actual high costs, thereby going towards equilibrium E, as we have discussed earlier, and increase the profits. So point being, if firm 1 has high costs, there is an incentive to claim to have high costs as well. So in the end, firm 1 will always claim to have high costs, because in either one of these situations, it is profit maximizing to claim to have high costs. In this part, simply lying in order to enforce a price-setting behavior of the firm 2 that is increasing profits of firm 1, and in this case by actually removing uncertainty and thereby increasing the profits of firm 1. Either way, in both of these scenarios, no matter what the true actual costs of firm 1 are, it always has an incentive to claim high marginal costs. Yeah, and that's exactly what's written here. Firm 1 will claim to have high costs independent of its actual costs. All right, so problem is firm 2 would lose profits if we went from these worlds, if we went from point E to point D, for example, right? So this of course leads to a problem. Firm 1 would lose, firm 2 would lose profits. Firm 2 can anticipate this behavior of firm 1, and under this assumption of non-verifiable information, any communication is non-credible, right? The idea is we know no matter what the actual costs of firm 1 are, they will always communicate to have high marginal costs. Firm 2 knows this, so they will knows that firm 1 will always claim to have high costs, so this claim does not bear any information, so it does not change the anticipate or the probability of the actual cost of firm 1 in any way, but rather firm 2 will still assume that firm 1 has low costs with a probability of 0.5 and the same probability for actually having high costs.